Hello, welcome. My name is Curtis Stubbs, Regional Precision Tools Sales Representative for Mitutoyo America Corporation, covering the North Central Illinois area here in Midwest.
Hi, I'm Wally Wardzala. I'm the product specialist. I mostly cover hardness testing products.
We would like to welcome you to our live event here on material testing and hardness testing. We're going to go through a lot of great material for you, the do's, the don'ts, what it's all about, and we're going to go through a few of our presentation slides here. And then from that point on, we're going to go and do some hands-on live, hands-on demonstrations of some of the equipment that we have here on display for you. Wally?
Okay, we're going to switch over to a slide presentation. There's a couple things that I want to accomplish. One is kind of as Curtis mentioned, the do's and don'ts of hardness testing, where to find the right information, things like that, and go over some of our new equipment. But there's a secret hidden agenda in here that you may or may not notice, but I'm trying to get you excited a little bit about hardness testing, to pay a little bit of attention to testing when you're doing it, dive a little deeper into the technical aspect of it. So we're going to get that started in just a second. Okay, switching over. Okay, so I can walk over to this now. Okay, so resistance of indentation hardness testing. So all the hardness testing that we're going to do is resistance to penetration type testing. There's other tests, but we'll go with that to start with. So my spoiler alert is no matter what type of testing you're doing, get the ASTM, the ISO, the JIS, the DIN spec, whatever version that you want to follow. Okay. So here's an example of ASTM test for Rockwell hardness testers. It's E18 is the Rockwell test. It's people look at it and go, oh my gosh, I can't read all that. It's very imposing. It's only 38 pages long, and of that, only 6 pages are really necessary to run the test.
Wow.
Okay. ASTM uses words like should and shall. Should is it's a good idea. Shall means you absolutely must. So in those 6 pages, it says should 22 times. It says shall 38 times. If you wanted to highlight the shalls and just read that part, you could get away with doing that. Okay. Some breaking ASTM news, just in case anybody wants to know. The 103,000 designation kind of failed. The HRB, the Rockwell B scale tolerances were opened up. Portable testers have been added to the main documents, sort of, and we'll go over that in a little bit more detail. Okay, ASTM, like all ISO and whatever, is a voluntary society. Okay, there's no hardness testing police to make sure that you do it right, unless you have an auditor standing over your back watching you, whatever. But it's just society or manufacturing or whatever has decided that these are the rules that we want to follow. Okay, there are no hardness testing police. Again, the auditors, you could have accreditation to NADCAP, A2LA, NAVLAP, your own personal corporate quality system. You could have written down rules that you follow that way. Okay. Unfortunately, though, when we talk about accreditation, the number one thing that pops up first in everybody's mind is the liability. If you don't do it right, you make bad parts, whatever, it's the liability aspect of it. Rarely do you ever hear anybody go, I want to make a better part. I'm going to do more hardness testing so I can make better parts. Nobody really wants to do hardness testing. It adds to the manufacturing costs, time, equipment, employees just to do the testing. Okay, so why test the hardness in the first place? Well, for years and years, Rockwell hardness testing, for example, is over 100 years old. Burnell testing is 120 some years old. It's been in use to rate materials for toughness, wear resistance, tensile strength, weld penetration, fitness for use, all different types of information that we can get out of running simple hardness tests. Okay, I have some customers that really, it's been around so long, all they want to know is, did it go through the heat treat process at all? Just a yes or no type of quick test. Okay, automotive parts, for example, like the lug nuts that popped up there, they're talking millions at a time. They run 1 million lug nuts, and it's important to get the procedure down to the point where you just need to check a certain percentage, and all the parts are good. Again, you have to, it's on the print. or this guy shows up again. Okay. But what if the print is wrong? I can tell you from experience that half of the prints that I look at are specified wrong, and probably 5% of those are, it's just not even possible. Maybe the engineer's wrong, maybe it's been passed down, maybe it's been translated wrong or whatever, but we all know how hard it is to get an engineer to change a print. It's like pushing a boulder up a hill. Okay. Again, we were talking about materials testing. Here's a list of tensile, Sharpie, fatigue, ductility, and hardness is generally at the bottom of the list. Okay. The reason for that is it's not a fundamental property of the materials. It's more of a process type control. Okay, so it's a fast, easy, cheap test to run, but it might not be as useful as, say, a tensile test for your application. Okay, so again, all the hardness testing that we do is resistance to penetration. Just a quick run through of some of the tests that led to where we are today. The Mohs test, everyone's probably familiar with that. If material A scratches material B, it's harder. Okay. Scratch test was in the 1850s for testing, rudimentary heat treating things, gun barrels and things like that. Next test that got popular though was the first real hardness test that we still use today, the Burnell hardness test. We'll go through these a little bit more in detail when we get to the machine. The Vickers test was a little bit later, but it's very, very similar test to the Burnell test. It just uses different loads and different indenters. The Rockwell hardness test, 1922, and that's one of the first ASTM standards. E18. It's early on in 1934, I think it was started. Okay, durometers were from the 1920s as well. Okay, and the Berkovich is probably one of the most sophisticated tests we have today, and that's from the 50s.
Oh, wow.
So there's really not a whole heck of a lot new under the sun. So when someone gives you a sample that they want to do hardness testing on, the first thing you should ask them is, how hard do you expect it to be? And the reason you do that is maybe accidentally they'll give you some of this other information. Maybe the test method, maybe the load you want to run it at if it's a Vickers or Burnell type of test. What indenter you want to use, or if they're using any corrections, scale conversions, cylindrical corrections, things like that. Okay. Most time what most people do wrong is in their reporting process. Okay. If someone said, hey, this thing's supposed to be 45.8, you'd be like, 45.8 what? Okay. If they said B45, there's a really good chance they mean the Rockwell B scale, but you still couldn't be absolutely sure. Okay. The only correct method, and that's going to be in your ISO or ASTM or any, maybe your quality system, the only correct way to report Rockwell B scale is 45.8 hardness Rockwell B with a tungsten carbide ball. Okay, we still have some customers that use a steel ball. They're required to write HRBS on the list. Okay, if you use corrections or conversions to other scales, okay, here's the way you might want to do it. Say 45.8 Rockwell B is approximately equal to 33.3 on the Rockwell A scale. If you use conversions and don't say that you did, how would anybody know how you did the test? Okay. Again, if that judge comes up again and, well, how do we know you did this test? Or how do we know it's not written down? There's no proof. In fact, if you're selling parts to someone else based on hardness values, you should probably list the method that you used, ASTM or ISO or whatever standard that you used to further back up what you've done. On the Burnell and Vickers scale, same situation exists. 450, I could guess, but I don't know what test method. Okay, if I said it was 450 Burnell or 450 Vickers, yeah, that would be a really good indication, or HB or HV. But again, ISO, ASTM, you must list not only the indenter that you used, you must list the test force that you used. So 450 hardness, Burnell, tungsten carbide ball, 10 millimeter ball, 3,000 kilograms. This is the only problem spot right now. ASTM, ISO, everyone says you must do it like this except for this one. Okay, this is really kind of a disappointment. This just failed. We tried to get this changed in ASTM that you must list 10-3000, but the industry, the people who use it says that's too much work. So the real problem here is someone can say 450 HBW and they would be technically right, and you're supposed to assume they used a 10 millimeter ball with a 3,000 kilogram load. And if they don't, again, it's just an assumption. So if you use any scale, any ball, list it after your Vickers or Burnell number. So why all the different scales, especially on the Rockwell scale? Okay, well, it's what are you testing and what do you want to know from the part? And we're going to get into a few examples of that in just a second. For example, in the macro world, macro would be like this disc rotor. Okay, the middle picture is someone took a little ball, a little grinding paper, I'm sorry, and ground a spot, and they did a Burnell test on there with a 10 millimeter ball, and they get about a 2.5 millimeter diameter. But the picture on the right shows you what's happening on that material. One of the reasons Burnell is still around today, even though it's a lengthy test and you need a big piece of equipment, is look at the area of the part that it's covering. There's graphite in there, there's ferrite, there's carbides, there's all kinds of constituents in that particular material, and the Burnell test takes that all into consideration. It's such a large indentation that you get that. Okay, so this would be what's happening at the test level. You measure the two diameters of the ball with a Burnell scope, which is in the upper right. Not a very good picture, but it's showing that, yeah, that indentation was about 2.5 millimeters. So a couple more macro applications. Again, castings is a really good Burnell application. Pipeline, the oil industry uses a lot of Burnell type of testing, and there's some aluminum extrusions shown in there as well. Okay, aluminum has silicon particles and might have voids in porosity if it's a casting and things like that. Okay, the Rockwell test is a great test for a macro test because it's faster, the equipment's less expensive, the operator doesn't have to do any work, the machine more or less spits out the number. It can work on much smaller parts, it can work on much harder parts. So again, over the years it's gained a great popularity, but it's kind of on the opposite side of the macro scale because it doesn't work really well on castings, although there are Rockwell E scales and other scales that can be used in castings as well. This picture kind of shows you why the Rockwell test was invented. Heat treaters in the olden days, maybe the 1900s, would roll ball bearings down a little track, and the ones that bounced far were the hard ones, and the ones that went thud were the soft ones. And the Rockwell test interested Stanley Rockwell. It caused him to create this test because he wanted to know why. He wanted to know how can you tell which are going to be the hard ones, which are going to be the soft ones. This is the Rockwell test. There's 3 different pictations of the same exact thing happening. The first one shows what's happening with force. Okay, the minor load that you applied. Okay, then it's increased to the major load. It goes back down to the minor load. And then you actually make your Rockwell measurement, the differential, the permanent deformation of the part. And the very bottom picture shows you that same situation with the indentation going into the sample. So we have 15 Rockwell scales. Again, people get confused, which scale do I want to use? ASTM has a guide, the ISO spec has a guide, but you can pretty much guess that if it's a heat-treated part, it's probably going to be a diamond scale. And if it's a raw material part, it's probably going to be a ball scale. So 15 scales with just 3 test loads. The Rockwell is 60, 100, or 150 kilograms, and you change the indenters from diamond, 16th inch ball, 1/8 inch ball, 1/4 inch ball, 1/2 inch ball, and you get the 15 Rockwell scales. Okay, so if you have a Rockwell machine, it theoretically is capable of all 15 scales. You might not have all indenters to start with, but it's capable of that. The superficial scale is almost the same idea. There's 15 scales, 3 different loads, 5 different indenters, the same 5 different indenters, okay? But let's go back a little bit in time to the older machines that might use a dial on there. And this really it explains how the Rockwell test came to be. It was one revolution of a dial indicator back in the day. One whole Rockwell number was 2 microns or 80 millionths of an inch travel on a dial indicator. And the superficial scale is twice as sensitive as that. It's 1 micron or 40 millionths of an inch. Okay, but if you notice on there, there's 2 different scales, inside, outside. The red is the B scale. It resets at 130. The C is the black scale on there. There's also the green scale for the superficial, but this is the only picture of a dial indicator that I could come up with. Another great thing about the Rockwell test is ASTM has all these rules written down. You want to know the minimum thickness? Go to the ASTM spec and it says, here's a minimum thickness chart. You want to know cylindrical corrections? It's all in there. You want to know scale conversions? That's in there too. Okay, it's a very, very good reference source to find all the answers to your questions. So let's go to the other side of the testing situation. Okay, we were talking macro before. Now we're going to look at micro hardness. Okay, we want to know exactly how hard something is in a particular location, in a certain area, or across a particular part. The picture on the far right is a plasma spray coating. You can see easily the small indentation in the hard flame spray part, and the larger indentation is the softer. Or the middle picture, you know, it's a 2-phase alloy, and you can check the hardness in the 2 different phases. So this is one of my favorite pictures because it's really, really a good demonstration of what's happening on this weld nugget. Okay, you have the 2 pieces that you welded together on the outside. Those are tested in the non-heat treated zone. You have the heat affected zone tested, and then you have tests in the weld nugget. Generally you don't etch samples, but in this particular application they did acid etch it to better show us what's happening here. Another application of the micro hardness tester is gradient hardness testing, where you heat treat something to put a case on it. That's sometimes called effective case depth study or CHD, or there's different names for it. But a good example or good use would be like a camshaft or gear shafts or axles, things like that. So let's take a closer look at that. And all of these are splined axle assemblies, and you can see the one on the far left, like 8 o'clock position, is a really, really heavy case, and you go counterclockwise and it gets lighter and lighter and lighter and lighter case on that. Okay, so you say, well, what good is that? Why do I need to test that? Why should I be concerned about that? Okay, well, the next picture shows this is a ductile failure. The part wasn't heat treated enough. It wasn't strong enough to support the amount of torque that was going in there. So they probably had a real thin case on that. Okay, the next picture shows the same type of shaft. That's a brittle failure. It broke because you can see the case on that is actually, looks like it's almost a 1/4 inch thick, and the part was just too brittle to work in its application. Okay, so if you were to, this is about a 50x macro picture. This is what they would have done to figure out the case depth on there. They would have done a series of hardness tests, starting from the outside edge and working their way in. And when they finally got to the core, where they would say our effective case depth is whatever, 50 thousandths or 100 thousandths or whatever it needed to be at that point. Okay. Next, we're going to switch to the products that Mitutoyo can offer. We ran into a little bit of glitch. We were going to go through these one at a time and show these to you live, which we're still going to do. But we found that if we switched from monitor to camera and back and forth, we had a little bit of an issue. So we have durometers, we have rebound tester. We do not have a full Burnell hardness tester like the basic American view is 500 to 3,000 kilograms. We do have baby Burnell or light force Burnell up to 250 kilograms. Those generally use like a 1 millimeter ball, 2.5 millimeter ball, much more popular European specification. We have heavy load Vickers machines. Those generally are 1 kilogram up to 50 kilograms. We have micro Vickers machines that are generally in the 10 gram to 1,000 gram range. And then we have our Rockwell type of testers. Okay, first we'll start out with the durometers, and again, we'll get a close-up of these in a minute. There's 12 different scales for durometers. We basically only care about the A and the D scale. The A is probably 70%, the D is about 10%, and all the other scales make up about another 10% on there. But we don't have real light load durometers and things like that. There's some pictures on the bottom, gummy bears to fiberglass helmets, kind of where they're used. Okay, we have the HH411, which is a rebound tester or a lead hardness tester. One of the great things about this is it's actually, there's an ASTM and ISO standard for these materials. There's several different probes that you can use on this, but basically it shoots a little carbide ball against the part, and we measure the difference in the velocity from before it impacted the part to after it impacted the part, and that gives us a hardness number. Okay, there's 3 parameters though that must be met. You can't pick the 2 you want. You need a mass of at least 10 pounds because it's an energy. There's a rebound action going on. You need a surface finish of about 63 RA, which is a nice ground surface. And you also need a wall thickness of 1/4 inch. That one, depending on the material, could be a little bit thin. If you have a brass or something that rings, you might want to have a little bit thicker than a 1/4 inch. And sometimes you're allowed to use couplings to couple it to a larger, heavier mass. Okay. Again, our Vickers testers, we do have an extended range machine that goes from 0.05 grams up to 2,000 grams. 10 to 1,000 is standard. We have a semi-macro machine that goes from 300 grams to 30 kilograms, and the typical macro Vickers machine goes from 1 kilogram to 50 kilograms. We have various levels of automation, and we're going to show you that in a little bit. You can add a camera to it. You can make an automatic reading system. You can make an automatic reading, automatic traversing, automatic focusing version on any of the Vickers machines. We have a complete line of Rockwell testers. We have 3 deadweight style machines shown there, the HR320 MS, which is a twin tester, both Rockwell and superficial in one machine. We have a next model up is just Rockwell only, but with an automatic brake start. And then the 430 MS is a twin tester with automatic brake start as well. Next, the last one on the right is the HR530 machine, which is a closed loop tester with automatic brake. Very, very popular machine. It's very economical, and yet it's still a really high performance hardness tester. Okay, just some of the features of that. We'll skip this till we get to the machine. The last machine that we've recently come out with is the HR600 machine. It's a large, heavy machine. It can do parts up to a couple 100 pounds. It's a motorized Z column, so basically it's a completely automatic tester. Just hit the go button and it's ready to test. And that can be automated and integrated into hardness testing cells as well. We have a full line of accessories, test blocks and denters, SPC software, wireless systems, quite a few choices to get your data out. We have the two common hardness tester questions that come up all the time is people ask about scale conversions, okay? And I cannot stress enough, if you use scale conversions, list them. List the actual test that you ran. All of our machines have built-in scale conversions, but they show you the scale you tested in the big number, and if you convert the data to another scale, it shows that as a little bit smaller number, just to show you what you're doing. So please, if you convert your data, you know, you're the only person that knows you did that, so write that down. Portable hardness testers generally were designed around a particular application. So they're usually really good at one particular application, but you really wouldn't want to take a lead style tester and start doing coin parts or stamped parts or thin sheet metal or things like that. It was not really designed for doing that. Okay? One of the things I think I showed you is the portable versions of the tests have been kind of added to the corresponding standards, but you're supposed to put /P to indicate that it's portable, and unfortunately I'm afraid people are going to go, yeah, that's close enough, when it's not really not really what they're trying to accomplish. Okay,
Right.
so if you use a portable Rockwell tester that doesn't meet all the requirements of the test method, you might want to write that down. Save yourself grief and aggravation later.
Just a thought, right?
Okay, so I probably mentioned ASTM and ISO quite a bit here, and I just wanted to point out a couple things here. If you join ASTM, it's $80 a year, and you get one free volume of their standards. Fortunately, everything for hardness testing is in volume 3.01 except E384, the micro hardness specification itself. Okay, if you were to buy that specification, just one, it's 67 to 75 bucks, something like that. So for 80 bucks, you get everything in one book, and again, it's a voluntary society. You don't have to vote. You don't have to read anything. It keeps you up to date on everything that's happening. And there's far less members than you might imagine that are actively involved in the standards themselves. You know, there's hundreds and hundreds of users, but there might be only a couple hundred people that actually participate in the standards. Okay, so what am I really trying to say here is whatever method you do, get the book, learn the rules, and report the answers correctly. And thanks for attending this presentation, but we're going to switch now to some live demonstrations.
And yes, before we get ready to touch on those live demonstrations, please do not forget to go ahead, like us, subscribe to our YouTube channel. Go ahead and like us and follow us on Facebook too as well. Any questions that you have, and I see them already flooding through here on my end, I mean, go ahead and get all the questions in there. We'll definitely get the answer, as many as we can here live for you. But we're going to go ahead and just touch base a little bit here on some of the Rockwell superficial type hardness testers, and also our manual system, our HR unit here. So, Wally, you want to go through a few differences here right now on this unit, or?
We had planned to start in the middle here with the Rockwell testers because that's the way my presentation was lined up, and really what I wanted to show you was the Rockwell process itself. Okay, so we're going to apply what's called the minor load or initial test force or whatever. If you're an old fogey, it's called the minor load, but generally it's thought of as the initial test force. So we're going to apply the minor load by raising up the elevating screw. Okay, there's a spring in there, and it's going to tell me when I reach 10 kilograms or 3 kilograms if I'm doing superficial, and you might be able to see it across the display panel. And when it gets to that point, it locks the elevating screw, and I can step back while it goes through the timers. Okay.
Oh. Now, Wally, for this one, in this case, you basically have like a little load here at the back that you can switch the weights to on the side, but then we also have another system that can do the manual load weights in the back of the machine too, correct?
Right. This is our mid-range machine. It's Rockwell only, but it does have the brake mechanism. Our HR320MS is a twin tester, but it has individual hanging weights in the back that you need to switch. That's a great tester if you want the capability to be able to do everything, but you're not really going to change very often.
Okay.
Okay. The dial weight system, where you just crank the knob in the back, is much faster. Okay. Again, it went through the timing function. It made the Rockwell test minor load, major load, came back to the minor load, and gave us our hardness value across the top. Okay. We're going to do the same thing over here on the HR530. Again, it does have the brake mechanism. I apply the minor load. It locks when it reaches the set point, and my timing functions come up. Timing functions are kind of interesting because in the olden days, the operator was supposed to have a stopwatch, and he would start and do his countdown and hit the stopwatch and stop the test when it was supposed to be. I've never seen a stopwatch being used at a customer ever. So if you have an old machine, you might want to look into that. Like what timing function should I be using? They're pretty wide, like 2 to 8 seconds, but you might want to look into your quality system to see if you do use need to use a stopwatch. Again, all the digital machines, it's all built into the machine. They're usually adjustable in 1 second intervals, so you can speed it up or slow it down. Okay. We're going to switch over now to our portable machines. Okay, we have our our lead tester, which is a small handheld device. There's actually, the carbide ball is mounted to a tup in here, and when you arm the device like this, that's all you need to do and test on the part. Okay. Again, this is the test block that we give you. You can see it clearly weighs 10 pounds. It has a nice mirror finish on it. Doesn't have to be quite that big. And you would just hold it on the part and get your leaf hardness. We have several durometers here. Dial durometers are still popular, although we have digital models. Very inexpensive. They're a few $100s. Whatever durometer you decide to use, I highly recommend going to a test stand. Okay. This is a combination A and D stand. It'll do both. Okay. The weight on there is just to go to excess of what you need to test on the part. Okay. Hold it for a couple seconds, take it off, and you get your hardness value on there. But whatever method you use, whatever scale you use, I recommend getting a stand. Now, these stands are pretty precision, and they're a little bit expensive. I don't care what stand you use. Get a drill press. Go to Harbor Freight, get a $39 drill press, and all you need is a metric screw to go into the top, and you can create your own.
And you know what, Wally, too, just to ask you another question, we get a lot of customers that says, hey, is it okay to do the hand test? Is this okay to do the hand roll and then touch, or no? And that's why we
you want to go perpendicular
to
the surface, and that's what's so good about the stand.
Exactly. Okay.
You get much more consistent results doing it that way.
So remember, not the hand, is best to use it with the stand, okay?
Right.
And don't forget to go ahead and drop your questions in there. Don't forget to subscribe, like us on YouTube, follow us, okay?
Okay. This is a fully automatic micro hardness tester, motorized XY stage, 3 megapixel camera, automatic focusing, all built into one. So not much to see when it operates. This rotates all by itself, and again, I don't think that'll show up too well on the camera, so we're going to go up to the screen. So we're going to switch to the actual operating screen. Okay. First thing I'm going to do is focus on my part. I can go to the automatic focus button, and it'll focus on the surface. Okay, I'm going to find a spot to test. Let me just find a clear spot.
And right now you're using a joystick.
I'm using the joystick to move it. I can click on the screen if I wanted, and it would go to that location as well. Or I could program in a traverse or something, a pattern that I want to run, and we'll do that in a second. But I can just hit the test button. It's rotating through. I've selected 300 grams in a previous screen. And one of the reasons why automation is so popular for these machines is, according to ASTM and ISO and all the governing bodies, it can't be speeded up. The dwell times, the impact rate of the diamond into the part has to be 70 microns or less. The dwell times are 15 seconds or so. So it really can't be speeded up. So the reason they're automated is you can walk away, do a bunch of tests, come back and get your data. So right now I have it set on shading correction, so it's evening out the screen for me, focusing and making our measurements. Again, the blue lines on there are the actual measurements itself. We can measure manually as well. Lost my mouse here. Okay, if we need to manually measure a part, it didn't come out right, it's not straight, the surface is too bad, you can also drag and drop, double click, move the filer lines like you would on a traditional hardness tester. Okay, so let's just clear that out for a second. Okay, we have wizards built in, so one of the wizards is to do a pattern. Okay, the first thing it asks us is what test we want to make. We're going to run a Vickers test. We're going to use 300 grams. We're going to measure automatically. Let me put that back. And we're going to use the 50x objective. Okay, what kind of pattern do we want to run? There's only 8 shown here, but You can create your own kind of pattern however you want by adding these particular patterns together, maybe a straight line connected to an arc or change.
And this makes it easier for the operator where they can just go ahead and hit the click button and then go over to their Rockwell machine that they got to the left of them and continue their other tests, right?
Right.
All right.
Okay, so
Okay.
this says I have 3 points selected. I'm going to use a offset of 50 microns to start with, and I'm going to test every 100 microns after that. Okay, so we'll say, oh, that looks like a good enough pattern.
Okay.
Okay, next. Okay, those 3 points come back. This is a really powerful screen that you may or may not use. For example, when you start very, very close to the edge of a sample, ASTM ISO, I'll say you have to be 3 diameters of your indentation away from the edge. Okay, well, if you have a big indentation, that means you got to be far away.
Right.
Okay, so what we could do here is just edit the first one and say, I only want to use 100 grams. And I still want to use my 50x objective and whatever, but I can change any of those parameters for any of the indentations. Okay, now they want me to determine my origin point. Okay, I can do just single point. It's always a perfect coordinate system, perfect x, perfect y, or I can define a plane, or I could define a plane and my start point direction.
Okay.
We're just going to do 1 point in this particular case, because we're just going to go x and y. Okay, and it's saying where do I want that point to be, and just random put it over there. I'm going to apply this pattern, hit end, and I could string many of these patterns together here. So if you were doing gear
Nice.
teeth, you could do both sides, you can do the root, the pitch, whatever you wanted.
Nice.
Just keep adding them there, but we're
Right.
only doing this one. So I'm going to say run. That's asking me yes. This is last version of software, but new one doesn't say that. So it moved at 50 microns that I wanted it to move away from the edge, or another indentation or inclusions or whatever. And it's going to go through, right now it says pattern 1, test number 1, and it's going to go through those 3 tests. I'm going to
Okay. And of course, as it's going through those 3 tests, again, we can definitely use this as an example of those out in the shop. In the measurement world of material testing, you can basically set your programs. Once these are saved, you can go ahead and hit the click button, the start button, walk away as it's completing its test, and go ahead and do some other daily duties that you have as far as within your shop or quality lab. So.
It's the last 3 indentations shown in that list that I opened up, and it says not calculated because it hasn't measured yet. Okay, measured, gone over to the next one.
Okay.
We'll let that finish off a second. Yes. What? Okay, so it's pattern number 1 again, and it's on test number 2, so you always know where you're at in the process.
Okay.
Okay, this same software can be used on the HR600, which we're going to show next. Not quite ready for it yet, but we'll let this finish off just so you can see our results here. And there's a report generator built into the software. As soon as it finishes, again, we'll open that up. I think we got one more to go. And just about done here. Again, you can't speed this part of the operation up, so good time to get a cup of coffee. There's certain things we can do to speed it up, but you know, if you're talking the difference between 35 and 31 seconds, is it really really worthwhile? Okay, so it automatically wants to save the data, which I'm going to skip this step for right now. Come on, mouse.
There you go. There you go. Okay.
Sorry. Okay, but we have a layout view, which is actually our report, and all of the values that we measure show up in this report. We can customize this pretty much however we want.
Add your images, right? JPEG images if you're saving a part, whatever the data that you want in there, as far as the test, etc. Right?
Put your corporate logos and things like that.
Very nice.
And all of this information is saved into the machine. If you wanted to regenerate this report in a month or two or whatever, you just click on the report and it would come right back up to this format.
Okay.
Okay, so again, that's a quick demonstration of it. You know, we're always happy to have you come into the showroom and try and run some parts, but we're going to switch over to our newest Rockwell machine, the HR600. Okay, as you can see, this is a substantial machine. It can hold large parts. In this version, the anvil is the table and it's fixed, but you can get motorized X and Y tables for it as well. Again, we have interfaces that you can hook it up to PLCs and other equipment if you have it in a robotic cell. But this is basically still a standalone version. We'll grab our part, put it up there.
And what's the max load you think you can put on type of those?
It's 100 kilograms,
Okay.
220 pounds,
Oh, wow.
whatever. On the motorized versions, it goes down because the stages can't support 200 pounds and the Rockwell test and everything else after that. So you could check on that, but I believe that's 50 kilograms.
All right.
Okay. The same kind of control panel that we have on the HR 530 over there, but the biggest difference is all I need to do, hit the start button, the head comes down on the Z-axis column.
And then you can also have these set up at an inline setup too as well, right, Wally, where we can kind of have multiple parts, running through an area, going through a PLC and stuff like that.
Yeah.
Okay.
Again, that's software is very, very similar to what we showed on the micro hardness tester, except it's doing a Rockwell test instead of a Vickers test.
Right.
Okay. Again, test over, results are there, and all of my information is displayed at once. There are several options to the display. You can have just a big hardness number if you want and get rid of all the parameters of the test and conversions and statistics and everything else. Or you can do like a running average of maybe 5 parts, and it'll automatically show you your trends from something set up like that.
Okay, great. So then I guess basically we done covered a little bit over from our hand portable systems, our shore hardness testers, also our fully automatic Rockwell hardness testers that go inline, near line inspection in your lab. Again, the ones with the dead loads weight sets, you can be able to have it manual, use the arm piece here on the side, do your continuous test. And with that saying, and I know we have a flood of questions here, we can be able to ask. So Wally, we can go ahead and get you ready. What we have going on here? Questions? Yep.
Do you offer analog dial type hardness testers?
Okay, you know, the Rockwell test, as I mentioned before, you know, one whole number is 80 millionths of an inch travel, and superficial is one whole number is 40 millionths or a micron. If you have a dial machine, yes, they just barely meet the requirements. The ASTM spec is plus or minus a half a number, and that's about all you can read a dial indicator to. So,
Okay.
you know, you're doing yourself a disservice by having a dial machine, but it's certainly a possibility. Next question.
That's the next question.
Do your hardness testers anvils come with a certificate that states the surfaces of the anvil are clean and smooth?
Okay.
Oh, good
There's
question.
really, you know, that's maintenance from your own, you know, quality system. You know, they should be cleaned periodically. Make sure they're smooth and flat, and nobody's made an indentation in there. But when we calibrate a hardness tester, and we do have A2LA calibration out in the field, we have a full service department that does that in the field. That's other than check to make sure you don't have an indentation on there. That is not one of the parameters that they normally go through. I mean, they clean it, but there's nothing that they certify or say it's.
Let's see if we can get one more in here. Go ahead. You got
Can I check a concave or convex surface with your Rockwell hardness testers? Is there a minimum or maximum radius that I'm able to check?
Okay, so all of that question, okay, was the first point I was trying to make, okay? All of that information can easily be found in the ASTM standards. For example, the smallest part diameter you can test is 1/4 inch on the Rockwell scales or an 1/8 inch on the superficial scales, okay? There's also corrections for, again, the cylindrical, both diameter. ISO also allows for spherical samples, but ASTM does not have a specific specification for that.
Okay, good. I think we can squeeze one more here just for the last. There's a lot of them. We're going to pick one more here for us, Paul.
Does your Rockwell machine also perform case depth, or is there a different type of tester I should be looking at if the case depth is on my print or calling out HRC?
Okay. Again, that you've hit just about everything that we covered today, right? The print's specified wrong, right? It's saying Rockwell C, but you want case depth right there. You're saying, or you're assuming that you can use conversions, okay, to do a micro hardness test. It's a micro test. You want to know how hard it is at a specific particular location. So it's going to be a micro Vickers type of test. If you wish to convert those to Rockwell C numbers, which many people do, that's fine, but you did a Vickers test and you're showing converted data.
Wow, great questions. Well, we do have a lot of other questions to get back to, and we do appreciate your time and joining us here at our live event. We hope you got a lot of information out here. Please don't forget to follow us on YouTube, subscribe, like us. If you have any questions, feel free to reach out to us, 888-Mitutoyo, and that's 888-648-8869. Again, my name is Curtis Stubbs, Regional Precision Tools Sales Representative from Mitutoyo.
Oh, and thanks for watching our presentation. Again, I'm the product specialist for hardness testing. Walter.wardzala@mitutoyo.com would get right to my emails, or my phone is 847-682-1628.
All right. Well, we appreciate your time. Have a great day. Stay safe.